cup of coffee and 1 cup of tea is $21. Simply based on this relationship, we can't really find out how much it's going to be for a cup of coffee and a cup of tea. But if I give you additional information, and we have both relationships contain both variables, so we can find out how much it's going to be for each. Let's have a look. Compare with the second one. The first one has additional 2 cups of coffee, and they do have the same amount of tea over there. The cost also, the first one increased $10. So which means that 2 extra cups of coffee cost $10 extra. So they're equal. So we can figure out 1 cup of coffee equals to $5. And in this way, to solve simultaneous equation is called elimination, because the cause behind this is try to get rid of one variable. For this case, is really cup of tea. So let's have a look what happened over here. Simply, if I want to get rid of that tea, I can see they have the same amount of tea over here, so hence I minus them. So use the first one to minus the second one, so the tea is gone. And that 2 is really use 5 minus 3. And the 10 is really 31 minus 21. So I simply actually use the first equation to minus the second equation to get rid of the t, which have the same amount. Alright, so if we do express things algebraically, which is use letters to represent something unknown, I can have C represent a cup of coffee and T represent a cup of tea. So let's have a look at the methods that we done before. We can apply over here as well. So we have first equation and second equation. We want to get rid of one variable, but obviously it's easier to get rid of t, because in both equations contain only one t, and both have the same sign. So hence I can use the first equation to minus the second equation, and the t will be gone. So 5c minus 3c give me 2c. T minus t is 0. And 31 minus 21 is 10. So 2c equals 10, c equals 5. We still have to figure out what b is. So we're going to sub c equals 5 into any of these 2 equations. So let's choose the second one. And 3c is 3 times 5, because c equals 5. And plus t equals 21. So that's 15 plus t equals 21. And so hence t is equals to 6. So let's have a look at the scenario. So we have 2 equations. We have to solve them to figure out what is c, what is t. The difference is the sign between before the c is different. One is plus and one is minus. What are you going to do to get rid of t? Are you going to plus them or are you going to minus them? The first one we minus them because they both have the same sign and have the same amount. And the second one, we're going to add them because they have different signs and they have the same number in front of t. So hence, that's what we're going to do. So we're going to label them first, and I'm going to use the first equation to plus the second equation. So 5c plus 3c give you 8c, plus t minus t, and that's actually give you 0. And then you have 31 plus 25 is 56. So hence c is equal to 7. Now we're going to sub c equals 7 back into any of these 2 equations. So let's use the second one, because that tends to be smaller, but both is okay. So 3c is 3 times 7, and minus t, and equals 25. So hence 21 minus t equals 25. What you can do is you can move that 21 to the other side. So hence I minus 21 to both sides. We have negative t equals to 4. And there is negative before t, so hence we're going to time or divide negative 1, and you can get rid of the negative. So hence t equals to negative 4. Alright, let's have a look at 2 more questions over here quickly. So over here, we still try to get rid of one variable, use the elimination. We can see the number before y is the same. Both actually got 2, and both the same sign. So that'll be easy actually if I minus the first equation with the second equation. And then y will be disappeared. The reason I'm not using the second equation minus first equation is because I can see if I use 20 to minus 28, it becomes negative. So try to get rid of, try to avoid negative. So hence I use first one minus second one. Now 2x minus x is x. 2y minus 2y is 0. 28 minus 20 is 8. So x equals 8. And then we can substitute x equals 8 into the second equation to find out what is y going to be. X, for this case, now is already equals to 8, and plus 2y, and equals to 20, and then minus 8 from both sides. So 2y equals to 12, y equals to 6. Next example, we have the same number before q, so it's 5, 5, but they have a different sign. So rather than actually minus them, we can actually add them together to get rid of q. So the variable we're going to eliminate is going to be the q. So let's label them 1 and 2. So we're going to use the first equation plus the second equation. 6p plus 5p is 11p. Plus 5q, and then minus 5q is give you 0. And that's equals to negative 22, and plus 0 is negative 22. So you divide both sides by 11, and p is equals to negative 2. And then we're going to substitute p equals negative 2 into any of this equation. Let's use the second one. And we have 5 times p, so 5 times negative 2, minus 5q equals 0. So negative 10 minus 5q equals 0. And we have plus 10 from both sides. So we have negative 5q equals to 10. The way to get rid of negative 5 is divide both sides by negative 5. So hence q is equals to 10 divided by negative 5. That's equals to negative 2 also. Thank you.